Hello friends, welcome to my channel nCoachingcentre. So today I'm going to explain about the 11th standard physics thermodynamic chapter. So let's come to the chapter thermodynamic. So it is the more painful to get burnt by steam rather than steam rather than steam rather than the boiling point is 100 degrees Celsius getting converted to water at 100 degrees Celsius, then it gives out 536 heat. So it is clear that steam at 100 degrees Celsius has more heat than the water at 100 degrees Celsius. So melting point. Conversion of solid into liquid state at constant temperature is melting, and evaporation is the conversion of liquid into vapor at all temperature is called as the evaporation. Boiling is the when a liquid is heated gradually at a particular temperature and saturated vapor pressure of the liquid becomes equal to the atmosphere pressure. Now bubbles of vapor rise to the surface of liquid, and this is called the boiling of the liquid. And sublimation, that is the conversion of solid into vapor state is called as the sublimation. And hoarfrost, it is conversion of vapors into solid state is called as hoarfrost. And the calorimetry, this is the branch of heat transfer that deals with the measured heat. The heat is usually measured into calories or kilocalories. And principle of calorimeter is when the hot body is mixed with a cold body, the heat lost by is equal to the heat gained by the cold body. Heat lost by the hot body is equal to the heat gained by the cold body. Is the principle of calorimetry. Heat lost is equal to heat gain is the thing of principle of calorimetry. Next is thermal expansion. There is three types of thermal expansion. Increase in size of heating is called as the thermal expansion, and there is three types in that. That is the expansion of solid, expansion of liquid, expansion of gases. Expansion of solid, how it happens is linear equation expansion in length on heating is called as linear expansion. So increasing in length, L2 is equal to L1, L plus A is the temperature into delta T temperature. Next is A is equal to delta L by L, therefore delta T. So where L is the real length and delta L is the change in length and delta T is the change in temperature. So superficial expansion. So expansion in an area on heating. Expansion in an area on heating is called as superficial expansion. And increasing of area, A2 is equal to A1, 1 plus B delta T. So therefore A2 is equal to A1 is the initial and final area, and B is the coefficient of it. So coefficient of expansion B is equal to delta A by A. Therefore delta T is the thing we get. A is the change in area and AT is the change in temperature. Next is cubicle expansion. So expansion in volume on heating is called as cubicle expansion. Increase in volume, V2 is equal to V1. So 1 plus delta T, Y by delta T. So here Y is equal to delta V by V into delta T. So where V is the real volume, AV is the change in volume, delta T is the change in temperature, and B is the coefficient, that is 2A, and Y is equal to 3A. So therefore A is equal to B. A is so therefore ratio A is ratio of B. Ratio they have given in the ratio form. A is equal to A is the B, so equal to Y. Therefore it is equal to 1:3, 2:3 they have given. Expansion of liquid. So in liquid, only expansion in volume takes place on heating. Only expansion of volume takes place. So Y is equal to apparent increase in volume, and original volume into by original volume into rise in temperature it is. And Y is equal to next is real expansion of liquid when expansion of the container containing liquid on heating is also taken place. So real increase in volume by original volume into rise in temperature. Next is anomalous expansion in water, that is when temperature of water is increased from 0 degrees Celsius, then its volume decreases up to 4 degrees Celsius, becomes a minimum at 4 degrees Celsius, and the increase of behavior of water or around 4 degrees Celsius is called as, so the increased behavior of water around 4 degrees Celsius is called as the anomalous expansion of water. Next, expansion of gas. So there are two types of coefficient of expansion in gases, the volume coefficient at constant pressure and the change in volume, and volume per degree Celsius is V is equal to V2 minus V1, VO is equal to temperature T2 minus T1. So therefore pressure coefficient at constant volume, the change in pressure per unit pressure per degree Celsius is called as pressure coefficient. So here pressure is changed into per unit per degree Celsius, and here change in volume per unit per degree Celsius. Here pressure change, here volume change, that's all. Nothing is there. Here P2 minus P1 by T2 minus T1, everything is same here also. So here nothing, here your pressure will change, volume in per unit, volume per degree Celsius will be here constant volume, here will be volume constant in the pressure coefficient, volume will be constant in volume coefficient, pressure will be constant, but here volume per unit volume degree Celsius per degree Celsius will come, here pressure per unit pressure degree Celsius will come. Next is practical applications of expansion. So when a rail is laid down on the ground, space is left between the end of two rails, so the transmission cables are not tightly fixed to the pole, so that the transmission cable and the iron rim to be put on the cart wheel is called always of slightly smaller diameter than the wheel. So a glass stopper jammed in the neck of the glass bottle can be taken out by warming the neck of the bottle. Important points is due to increment in its period, due to change in period, a pendulum clock becomes slow in summer and will lose time. So because of the increment change in its time period, the pendulum of the clock becomes slow in the summer season, and loss of time in a time period, delta t is equal to 1 by 2 a delta theta t. Loss of time becomes, and at some higher temperature the scale will expand and scale reading will be lesser than true value. True value of scale reading is 1 plus a delta t. Here hence delta t is the temperature difference. However, the lower temperature scale reading will become more and true value will be less. So, lower temperature will become more and true value becomes less. So thermodynamics. So thermodynamic system has an ensemble of extremely large number of particles whose state can be expressed in terms of pressure, volume, temperature. We can express the large number of particles in pressure, volume, temperature is called as thermodynamic system. And there are three types. One is open system, closed system, and isolated system. Open system, it exchanges both energy and matter with surrounding, and closed system is it exchanges only energy and not matter without surrounding. And isolated system, it exchanges neither matter nor energy, it exchanges with surrounding. So open, it exchanges matter and energy. Closed only, it exchanges energy. And isolated, it's not neither exchange energy or neither exchange matter. Next is thermodynamic parameter and or coordinates or variables. So the statement of thermodynamic system can be described by specifying by saying the pressure, volume, temperature, internal energy, and number of nuclei, etc. And these are thermodynamic parameter, it is called as. So to explain it by the temperature, internal energy, and number of moles, pressure, volume, by this if we explain it, then it is called as the thermoparameter or coordinates or variables. W work done is equal to P is equal to delta V. So P is pressure, delta V is the change in volume. So like this, it will be pressure will be at the y-axis and volume will be at x-axis when writing the graph. So work done in a process A minus B is equal to area A B C D A. So work done by thermodynamic system is taken as positive 4 as volume increase, negative 4 as volume decreased. I take like this. If it is positive, volume is increased. If it is positive negative 4, then volume is decreased. Next, internal energy. So the total energy possessed by any system due to molecular motion or due to molecular configuration. So the total energy that is possessed by a system due to molecular motion or the internal energy that we got the internal energy that we process due to any molecular motion or the molecular configuration. A molecular configuration is called as internal energy. So internal energy of thermodynamic system depends on the temperature it is the characteristic property of the state of the system. Next is zeroth law of thermodynamics. According to this law, two systems in thermal equilibrium. Thermal equilibrium we learned in part 1 video. Equilibrium with third system. The thermal equilibrium with a third system separately or thermal equilibrium with each other or separately with thermal equilibrium with each other. Thus if A and B are separately in equilibrium with C, that is if TA is equal to TC, I is equal to and TC and TB is equal to TC, then this implies that TA is equal to TB and the system A and B are also the thermal equilibrium. So system A and B are thermal equilibrium. It says that. And next is first law of thermodynamics. So he gave heat given to a thermodynamic system is particularly utilized in doing work against surrounding and remaining part increased to external energy, that is delta U of the system. So thermodynamic is equal to delta Q, that is thermodynamic system is equal to delta U, that is internal energy, plus delta V, that is doing work. So therefore delta Q is equal to delta W, delta U is 0 is equal to 0, so therefore delta theta is equal to 0, so therefore delta U is equal to minus delta W. So therefore in isochoric process work done is 0 and delta W is equals to 0, so therefore delta Q is equal to delta U, that is delta Q is the thermodynamics is equal to delta U, that is the thermodynamic is equal to delta U, that is the internal energy it is. So okay friends, till here you understand it. So okay friends, like the video, comment on my subscribe my channel and coaching center for more video. I will explain the next other topics in my last part 3 video. So till here you understand I think thermodynamics. So okay friends, bye. So take care, I will see you in my next video. Till then take care, have a nice day, bye my dear friends.